ESA's latest release wasn't supposed to happen yet. A single still frame leaked through the official archive, grainy, overexposed, and oddly symmetrical. Within minutes, astronomers realized something was off. The light pattern wasn't cometary diffusion, it was angular reflection. If that geometry is real, it rewrites everything we know about how interstellar objects behave near the Sunday. If you're following this mystery, make sure to like and subscribe so we can keep tracking it together in real time. Tell me in the comments where you're listening from and what exact time it is there. Now let's walk through what the ESA might have captured if the photo is genuine. It began as a whisper, an image that shouldn't have existed, appearing for only a few minutes before disappearing without a trace. A handful of astronomers saw it, saved it, and began to ask the question that would ignite weeks of speculation. Why did the European Space Agency upload a photo of 3I Atlas and then erase it? On the surface, the picture looked harmless, a dim blur surrounded by a faint halo, but its timing was impossible to ignore. It appeared right after the Mars flyby. During the one window when every probe around the planet was meant to be capturing high-resolution images. Someone had pointed a camera at the interstellar object, and someone else had quickly decided the world shouldn't see what it caught. Within hours, the image spread through private astronomy circles. Analysts corrected the exposure, cleaned the noise, and found something unsettling. The light wasn't scattered like gas or dust. It was tight, directional, as if reflected from a smooth surface. Ordinary comets don't do that. The question wasn't whether the photo was real. Too many people had confirmed its origin before deletion, but what it revealed. Why would a space agency risk credibility by pulling back a simple calibration frame unless that frame showed something it couldn't yet explain? Some believed it was an innocent mistake, an automated upload pushed before review. Others saw a pattern, a deliberate, carefully timed leak meant to release just enough to calm public pressure without exposing the real data. Either way, the silence that followed was louder than the image itself. When journalists asked ESA for comment, the agency responded with vague phrases about instrument diagnostics and data integrity checks. No one denied the image existed. No one clarified what it showed. That's how the mystery began. With a single picture that slipped through a locked system, a glimpse at an object that continues to defy every natural explanation we have. And for many who saw it, the unsettling part wasn't the blur on the screen. It was the feeling that someone, somewhere, had seen more and decided the rest of us weren't ready to. At first, no one thought much of it. The leaked image looked like every other faint blur in the night sky, a vague patch of light, a ghost on a sensor. But when astronomers began enhancing it, something emerged that refused to disappear. The more they cleaned the data, the clearer it became. This wasn't noise. It was a pattern. Light from comets is supposed to scatter randomly, softened by dust and gas streaming away from the nucleus. What we expect to see is chaos, a luminous fog shaped by solar radiation and chance. But 3I Atlas didn't behave that way. Its glow had order, faint edges curved into straight lines. Bright regions mirrored each other with symmetry that shouldn't exist in nature. When processed frame by frame, the structure rotated ever so slightly, like a wheel catching sunlight as it turned. Some called it coincidence, others called it impossible. For weeks, image analysts ran the frame through every filter and model available. Some tried to blur it back into nothing, assuming the human brain was just finding shapes where none existed. But the geometry remained. 6 luminous ridges arranged in near-perfect alignment. Not identical, just precise enough to feel deliberate. The object's glow seemed to rise and fall in rhythm, as if its brightness pulsed in measured intervals instead of random flickers. By the time those results circulated online, the term the hexagon had already spread through forums and late-night streams. People overlaid the shape onto diagrams of comets, satellites, even spacecraft blueprints, searching for something that matched. None did. No known comet, asteroid, or fragment ever recorded had displayed such a pattern of light reflection. In astronomy, repeated symmetry is the enemy of coincidence. Random forces don't repeat themselves this cleanly across frames. When the same lines appear at the same angles under different exposures, the odds of chance drop to near zero. And when they shift position as though rotating around a fixed axis, that's not static interference, that's movement. Still, the professional community hesitated. Many argued it had to be a sensor artifact, a trick of the instrument, Cameras can create reflections inside their lenses, bending light into patterns that don't exist in the sky. But even that explanation started to crumble when independent researchers using different techniques found the same geometry after processing the data from scratch. If it were an internal reflection, each instrument would produce a unique shape. They didn't. The angles matched within 1 degree. One researcher in Kyoto noticed something else: the color variation. The outer halo of 3I Atlas wasn't just brighter, it was warmer. A soft gold tone sat inside the otherwise cold white field, as if sunlight were reflecting off something metallic before bleeding through dust. Natural comets don't do that either. Their light leans blue from ionized gas. Gold means reflection, not emission. The discovery rippled through the scientific community. Was this a sign of internal structure? A crystalline nucleus aligned just right? Or something more engineered an arrangement, not an accident? No one could say. The European Space Agency remained silent, refusing to comment on unverified analyses. But silence has a sound of its own. It creates space for imagination to fill the void. And as the image of the hexagon spread reposted, remastered, debated, it stopped being a curiosity and became a warning. Because in astronomy, chaos is comforting. Randomness means nature is in control. But the moment you see pattern in the noise, the universe starts to look like it's thinking back. Light tells the truth even when people don't. Every comet ever studied carries its own fingerprint, a spectral signature of what it's made of. Hydrogen sings in one frequency, oxygen in another. Iron glows orange, nickel green, carbon cyan blue. When scientists split the light of a comet through a prism, they don't just see color, they see chemistry. That's why the next development stunned the community. When a small group of astrophysicists analyzed the leaked image's brightness ratios comparing how much light came through in red, green, and near-infrared bands, the numbers didn't fit any known cometary model. The reflection profile was reversed. Instead of scattering more blue light, as icy dust normally does, 3I Atlas glowed gold. The pattern suggested something dense, metallic, and smooth, like a surface built to reflect, not emit. At first, most dismissed it as a calibration issue. The sensors could have misread the scene because of saturation, or perhaps solar glare had skewed the data. But then another observation surfaced. A faint absorption dip in the near-infrared band where water ice should dominate. It wasn't just missing, it was inverted. In spectral terms, that means the object was reflecting light it shouldn't have had access to. While absorbing light, it normally would have reflected. To the naked eye, that explanation sounds abstract. But to anyone who studies spectroscopy, it's equivalent to hearing a human voice echo underwater, technically possible, but physically wrong. Natural comets obey simple physics. As sunlight hits the surface, volatile ices evaporate, releasing gas that forms a halo. That halo scatters short wavelengths, the blues more efficiently than the reds, giving comets their cold glow. Metallic surfaces, on the other hand, do the opposite. They bounce back longer wavelengths, creating warmth in color, a golden reflection rather than a blue shimmer. 3. Atlas was radiating warmth from deep space while remaining too cold to emit any of its own. One researcher compared the ratios to laboratory data from nickel-iron alloys. The match wasn't perfect, but close enough to raise eyebrows. The same metals often found in spacecraft hulls and meteorites, but never in vapor form at such distances from the Sunday. The finding was published quietly in a technical note before being withdrawn days later, pending data verification. Yet by then, the graphs had already been copied, archived, and shared. When the discussion reached open forums, theorists proposed explanations ranging from plausible to terrifying. One camp suggested that 3I Atlas might contain regions of pure metal embedded within a carbon shell, a kind of natural geode forged in a supernova. Another proposed that the spectral inversion was the result of coherent reflection, similar to the way optical satellites amplify certain wavelengths for power regulation. That idea was quickly dismissed by most institutions, not because it was impossible, but because it implied design. Meanwhile, amateur astronomers began their own tests. Using broadband filters and stacking techniques, they replicated the color trend from Earth-based telescopes. A subtle but consistent golden hue, distinct from any known cometary tone. The object's reflected light intensity varied in rhythm, as though it were modulating with solar position brightening when facing the sun directly. dimming when tilted away. Something about 3i Atlas was interacting with light consciously, or at least predictably beyond what simple outgassing or rotation could explain. For those who wanted to believe in the ordinary, this was the moment when the data began to resist them. Every correction, every recalibration, only made the anomaly clearer. The numbers didn't lie. They repeated themselves across instruments, across agencies, across oceans, and behind that golden glow, one truth began to form. Something in our solar system was breaking the spectral rules of nature itself. Heat is supposed to tell the truth. It's the one measurement that can't fake itself. No matter how strange an object looks in visible light, its temperature always gives away what's really happening beneath the surface. When a comet grows brighter, it's because sunlight is striking its icy crust, vaporizing volatile materials, and throwing gas and dust into space. That violent process releases energy warmth that radiates in infrared. The brighter a comet gets, the hotter it becomes. It's one of astronomy's oldest and simplest equations, but with 3i Atlas, that equation broke. When the European Space Agency released its limited thermal readings from the Mars Trace Gas Orbiter, the data looked inverted. The object's visible brightness was increasing rapidly, suggesting outgassing, movement, energy, yet the infrared sensors registered almost no heat. The readings hovered around -180 degrees Celsius, cold enough to freeze carbon dioxide solid. In other words, it was glowing without warming. At first, scientists blamed the instrument. Maybe the calibration was off. Maybe the camera wasn't sensitive enough at those distances. But then, other observatories began to report the same thing. The infrared sensors aboard the Hope orbiter and China's Tianwen-1 spacecraft both detected a similar profile. An object far brighter than its temperature should allow. It was as if 3i Atlas was emitting light that didn't come from heat at all, reflecting, not radiating. To the untrained eye, that might sound harmless, but in thermodynamics it's a paradox. Brightness requires energy. Outgassing requires sublimation. Sublimation requires heat. Remove any step, and the sequence collapses. Yet somehow, 3i Atlas skipped the middle entirely. It behaved like a mirror in deep space, shining fiercely while remaining frozen solid. The next anomaly came from spectroscopy. Every time the object's brightness fluctuated, the emission spectrum stayed flat. No thermal spikes. No hot dust signature. No infrared tail like ordinary comets produce when they shed material. It wasn't releasing heat, it was redirecting it. Some suggested that the surface could be covered in ultrafine metallic grains, acting like a thermal shield, reflecting solar radiation away instead of absorbing it. Others wondered if the surface layer had electrical properties, interacting with the solar wind to produce light without raising temperature, a kind of plasma reflection we've never observed on a natural body. Avi Loeb described it best. It's like watching someone sweat in a freezer. There's no. And still, the mystery deepened. Over several nights, astronomers noticed a rhythmic fluctuation. The object brightened and dimmed on a cycle of just under 3 hours. Natural rotation could explain that if one side reflected sunlight differently than the other, but the thermal readings didn't match the rhythm. Even when the visible light peaked, the infrared curve stayed flat. The energy was going somewhere, but not into heat. That observation spawned a new hypothesis, one that made even seasoned scientists uncomfortable. If the object was layered with materials that could redistribute absorbed energy internally, it might function more like a capacitor than a rock. Instead of heating up, it could store energy and re-emit it later in specific directions. Nothing in conventional astrophysics predicts such behavior for a natural body. It would require fine-tuned structure, composition, and control. But there it was, flickering across instruments thousands of kilometers apart, defying every rule in the thermodynamic book. By mid-October, the anomaly became undeniable. 3 independent research groups confirmed the thermal inversion. One agency quietly pulled its public data set offline, citing instrumental irregularities. Another reclassified the readings as non-conclusive, yet the numbers had already been downloaded, archived, and analyzed by dozens of independent scientists. The story was out. A comet that shines without heat shouldn't exist, but it does, and it's moving closer to the Sunday. The first thing you learn in observational astronomy is that everything moves. Stars drift, planets orbit, Comets race along their paths with measurable speed. Motion is what proves their real parallax. Doppler shift. Changing coordinates. Every celestial body leaves fingerprints in time. Which is why what happened with 3I Atlas left even the most rational observers uneasy. During the Mars flyby sequence, multiple probes captured short imaging bursts meant to track its trajectory. The frames were taken seconds apart, a method designed to measure movement by comparing background star positions. But when analysts aligned those frames, the object didn't shift at all. It stayed perfectly centered. Stars moved, dust moved. 3I Atlas did not. For several seconds, maybe minutes, it appeared frozen against the background of space. At first, it was written off as a tracking error. The camera could have been locked on the object, compensating for its motion and making it appear still. But the metadata showed the opposite. The tracking was disabled. The image system was fixed to a static star field. In other words, the stars should have remained steady while the object streaked across the frame. Instead, the inverse happened. The comet stood still while the cosmos drifted around it. That alone wouldn't be alarming if not for what followed. When the next imaging burst came in minutes later, 3I Atlas had jumped forward along its orbit by a measurable distance. Not gradually, not smoothly. A leap. A shift of several hundred kilometers with no visible transition between the 2 points. Physicists began arguing about frame timing. Maybe an exposure gap caused the illusion, but independent timestamps confirmed continuity. The object had paused in motion relative to every nearby reference point, then resumed as if someone had hit play. This is where the language of science starts to sound like fiction. Comets can appear to slow down when ejecting material that changes their center of mass, but they don't stop. Even the slowest natural objects move in continuous curves governed by gravity. To halt completely in its trajectory, even for seconds, would require external control or an interaction powerful enough to counter both its velocity and the sun's pull. Avi Loeb's team modeled the data, running orbital simulations. None could reproduce a stationary frame without invoking some kind of active thrust or electromagnetic braking. That possibility, an interstellar object capable of maneuvering, echoed the same suspicion raised years earlier with Oumuamua, but this time the evidence was clearer, sharper, and recorded by multiple platforms at once. Still, not everyone accepted the conclusion. Some argued the freeze was an illusion caused by the object rotating along its axis, briefly presenting a perfectly reflective plane toward the observer. A mirror angle that erased the illusion of motion. But that would have produced a spike in brightness, not a plateau. Instead, the object's light curve remained stable, unwavering, consistent with a true standstill. Then came the radio data. During the same interval as the freeze, one of the Mars relay satellites picked up a narrowband fluctuation, a faint pulse lasting less than a second. It wasn't a signal, at least not in any conventional sense, but it matched the time window of the object's apparent stillness. Coincidence? Maybe. But it added a new layer of unease. For the first time, astronomers were forced to consider that what they were observing might not be entirely passive, that an object traveling through interstellar space at tens of kilometers per second could decide, even for a moment, to stop. And that realization changed the tone of every discussion that followed. Because the silence of space had been broken not by noise, but by stillness. When astronomers describe a comet's light, they talk about diffusion, how sunlight scatters through dust, forming soft gradients that blur into space. There's a kind of beauty in that randomness. Nature doesn't draw straight lines. So when geometry appears in light, it always means something unnatural is at play. Reflection, refraction, interference, or construction. That's what made the latest analysis of 3I Atlas so unsettling. The faint structure hidden inside its luminous coma wasn't random, it was ordered, and the deeper scientists looked, the more that order refused to go away. It started when independent researchers layered the clearest images of the object taken during its closest approach to Mars. When aligned by their star backgrounds, the inner halo of 3I Atlas revealed repeating brightness contours not circular, not even elliptical, but polygonal. At specific angles, faint ridges of intensity curved into near-perfect arcs that joined at sharp intersections. The shape resembled the skeleton of a dodecahedron, 12 planes reflecting light in a synchronized pattern. At first, most assumed the pattern was an optical illusion caused by internal reflections in the camera, but that explanation fell apart when other spacecraft captured the same shape from completely different viewing angles. The polygons shifted slightly, but their proportions held steady, as if they were part of an underlying structure. In visible light, the pattern looked faint, a whisper of geometry beneath a mist of dust. But when those same frames were run through polarized filters, the lines flared up like hidden wiring suddenly illuminated. Polarized light is sensitive to texture. Smooth surfaces reflect it uniformly, rough natural ones scatter it in chaos. The light from 3i Atlas wasn't chaotic, it was disciplined. It followed angles. Some thought it could be magnetic, perhaps dust grains aligning with the solar wind, forming crystalline planes that bent sunlight in symmetrical ways. It's not an impossible theory. Magnetic alignment has been seen in interstellar dust clouds before, but not at this scale, and not in a coherent 3D pattern locked to a rotating body. For that to happen, 3i Atlas would need to generate a stable magnetic field of its own, something no known comet has ever done. Then came the rotation models. As the object spun, its brightness pulsed rhythmically every 182 minutes. When plotted over time, the peaks and troughs formed a wave pattern but not a natural sine curve. It looked more like a digital modulation signal. Each crest carried a geometric interval, a ratio of 1 to 2 to 4. When light patterns mirror mathematical sequences, scientists usually think of crystals, lattices, or resonance systems built to repeat. But in this case, the numbers lined up too cleanly, as though the object's brightness was encoding something. For a few days, discussion of geometry in 3i Atlas trended across scientific forums. Some called it the architect's glow. Others mocked the idea, calling it wishful thinking by people desperate to see design where none existed. But skepticism only strengthened curiosity. ESA's own analysts quietly ran Fourier decomposition models on the light curves, a way to translate patterns into frequencies. The result? Harmonic ratios that matched the polygonal symmetry seen in the imagery. The light and the structure were connected. That shouldn't be possible for a natural comet. Random chunks of ice and rock don't synchronize their brightness with the geometry of their shape. It's like watching lightning strike in perfect rhythm, beautiful but wrong. By mid-October, one quiet consensus had begun forming among the researchers who dared to talk off the record. Whatever 3i Atlas is, it isn't shapeless. There's framework in its light form inside the fog. And the deeper they looked, the more that glow began to feel like a message written in geometry, pulsing silently through the dark. It took a few weeks for anyone to notice. The leaked image had already been dissected by every major astronomy forum, every independent analyst, every curious amateur. Yet buried deep inside the data, something didn't add up. The photo's digital signature, the one attached automatically by the spacecraft's imaging sequence, didn't match the others from the same batch. Each file in ESA's archive carries a time code and a frame index, a simple way to track the order of exposures. But this one had a gap. The sequence jumped from frame 2048 to frame 2050. Frame 2049, the one between them, never appeared in the public logs. And when engineers tried to cross-check the telemetry timestamps, they discovered something stranger. The missing frame wasn't deleted. It was overwritten. Inside the metadata of the released image was a second timestamp, hidden in the hexadecimal data, a residual imprint left when one image is replaced by another. It pointed to a moment 6 seconds later than the recorded capture time. In plain language, that means the camera had taken one more picture that no one was meant to see. Why does that matter? Because in deep space imaging, 6 seconds is an eternity. At 67 kilometers per second, the object's estimated speed, 3i Atlas would have traveled almost 400 kilometers in that time. Enough for any detail or shape to shift noticeably. A single missing frame could hide an enormous amount of motion. When analysts reconstructed the camera's timeline using orbital data, they realized something else. The exposure gap coincided exactly with the moment the object appeared to freeze in place. The same anomaly that baffled mission controllers days earlier. The public frame, the one that leaked, shows the object perfectly centered, glowing faintly against the star field. The next recorded image, frame 2050, shows it shifted slightly ahead. Motion resumed. So what did frame 2049 capture? ESA has never said, but within private circles, Speculation exploded. Some believed the missing frame was simply corrupted data, a common occurrence in deep space telemetry. Others weren't so sure. The checksum verification string for that time segment is valid, which means the image did exist, was transmitted successfully, and then replaced in the archive with a duplicate header. In data science terms, that's not corruption, that's deletion with intent. One internal memo, quietly leaked to journalists, described the anomaly as a photometric event inconsistent with background expectations. That phrase appeared nowhere else in ESA documentation. The few who read it began calling frame 2049 the invisible photograph. Those who had access to partial logs said the raw energy profile spiked briefly. During that window, a flash of reflected light so intense that it saturated the sensors, forcing the onboard computer to auto-adjust and skip the following exposure. Others think the system didn't skip. It paused. Some unknown mechanism, external or internal, interrupted the imaging loop for exactly 1 second before restarting. There's no way to confirm which version is true because the raw data packets were purged after a checksum mismatch triggered automatic overwrite. What remains is only a breadcrumb trail, a ghost time code, and a missing number between two still frames of history. To most people, that would sound like a trivial technical glitch. To astronomers who live and breathe data continuity, it's something else entirely. You don't lose a frame in the middle of a controlled imaging sequence without reason. You certainly don't overwrite one unless someone, somewhere, decides that what it contains shouldn't exist. In the quiet corners of research networks, one uncomfortable theory has taken root that the missing frame didn't fail. It was hidden. Because whatever 3i Atlas did in those 6 seconds, the instruments saw it, and someone made sure the rest of us wouldn't. It didn't happen with a press release or a breaking headline. It began with a small, silent change to a web page, one that almost no one noticed. The European Space Agency quietly edited its online archive, replacing the original 3i Atlas update with a shorter, sanitized version. Gone were the mentions of unexpected reflectivity. Gone were the quotes about unusual photometric response. Even the image that had briefly circulated, the one everyone had been analyzing, disappeared from their media. In its place sat a new line of text. Further review of observational data is ongoing. Preliminary imagery has been withdrawn, pending calibration. To most readers, that sounded harmless, the kind of bureaucratic housekeeping that happens all the time. But to those who'd been tracking the data since day one, the retraction felt deliberate. The agency hadn't just paused communication. It had rewritten the record. The first clue came from cached versions of ESA's page, stored automatically by independent web archives. Comparing the original and updated statements side by side revealed subtle but significant differences. Phrases like high reflectivity had become variable brightness. References to structural geometry were replaced with instrumental artifacts. It wasn't just an edit, it was a reframing of reality. Then came the internal leak. An anonymous ESA engineer reached out to a European science journalist with a simple message. They're nervous about the light curve. The light curve, the graph showing how the object's brightness changed over time, had apparently revealed patterns that didn't match any known natural behavior. Peaks and troughs repeating in intervals too precise to be random. Engineers had debated whether to publish the full data set, but senior administrators allegedly ordered it withheld until context could be established. In space agency language, that often means, until we can explain it without panic. When reporters pressed ESA for clarification, the agency issued a statement that raised more questions than it answered. Instruments occasionally produce false patterns when interpreting fast-moving objects near strong solar interference, it read. Yet solar interference wasn't an issue in the Atlas sequence. The sun was several degrees below the field of view. The explanation simply didn't fit the data. Behind closed doors, researchers began whispering about inconsistencies in the timeline. Internal memos showed that a review meeting on October 9th had specifically discussed optical coherence within the target's emission structure, a phrase that doesn't belong in a conversation about a normal comet. Within 24 hours of that meeting, ESA's communications team pulled the public images offline. Across the Atlantic, NASA followed suit. Their official site removed mention of the 3i Atlas imaging collaboration entirely, citing the ongoing government shutdown as a reason for limited public updates. The coordination was uncanny. 2 agencies, on 2 continents, both going dark at the same time over the same object. By mid-October, the narrative had been rewritten. ESA now described 3I Atlas as a faint interstellar visitor, exhibiting typical cometary activity. The word typical carried weight. It was the agency's way of signaling closure, an attempt to steer the story back toward comfort. But outside the official channels, the silence only deepened the suspicion, because science doesn't delete its own data without reason. It flags, it corrects, it updates. Retraction is something different. Retraction means information was released, reviewed, and then removed. It means the facts didn't fit the story, or that the story was never meant to fit the facts. And so the brightest image humanity had ever captured of an object from another star system was quietly erased from the official record. No explanation, no apology, just absence. In astronomy, the dark is easy to study. It's predictable, patient, silent. But deliberate silence, the kind that follows discovery, is something else entirely. It's the sound of truth being managed. Mars has always been the planet we watch the closest. Its orbit is tracked by more probes than any world besides our own 6 active spacecraft circling above its red deserts, each equipped with cameras, spectrometers, and radio antennas. In theory, it's impossible for all of them to go silent at once. In October 2025, that theory failed. It started subtly. The data streams from MRO, Hope, and Tianwen. One began showing small upload delays, then extended blackouts. Routine telemetry, the heartbeat of every orbiter, stopped updating on public dashboards. Even the European Space Agency's Trace Gas Orbiter missed its daily packet. 4 different missions, 4 different agencies, all entering communication pauses within a 24-hour window. Officially, the reason was simple: scheduled maintenance. Unofficially, nothing about it made sense. Maintenance cycles are staggered between missions specifically to prevent data gaps. Spacecraft don't all take a break together. Yet that's exactly what happened right when 3I Atlas was nearest to Mars. By then, the global astronomy community was desperate for answers. The interstellar object was moving into the final stage of its solar approach, its most active, most visible period. Every probe in Martian orbit had been positioned for that moment. They were supposed to deliver high-resolution images, chemical readings, and thermal maps. Instead, silence. NASA's social channels offered bland reassurance. Due to the ongoing government shutdown, routine updates are temporarily delayed, but the timestamps betrayed them. The first communication drop occurred 8 hours before the shutdown order reached the Jet Propulsion Laboratory. ESA's data feed stopped 30 minutes later. Within another hour, China and the UAE followed. Different agencies, different governments, same blackout. When amateur astronomers noticed the absence, speculation erupted. Some suggested it was a precaution, an automated lockdown triggered by a solar flare. But the solar observatories at the same time reported calm space weather. No coronal mass ejection, no radiation spike. Others believed the orbiters had seen something they weren't cleared to share. Whispers began circulating among mission insiders. A European contractor claimed that the Trace Gas Orbiter had detected a spurious electromagnetic echo, a repeating signal bouncing between Mars and the object. A technician from NASA described the same pattern as a faint ping that didn't belong. The story sounded like rumor, but it spread fast because it explained everything. If the probes were picking up anomalous transmissions, agencies might have pulled their links offline to isolate the data. In mid-October, ESA issued a brief update stating that communication stability has been restored, yet no new images were released. The missing days, October 5th through 8th, remained unaccounted for. It was as if a portion of Mars' orbit itself had gone dark, a blind spot wrapped around the planet. To outside observers, it might have been dismissed as coincidence. But for those watching 3I Atlas, the silence felt intentional. It was the same week the leaked frame vanished from ESA's archive. The same week the light curve data was retracted. The pattern was impossible to ignore. Every time the object did something unexpected, the eyes watching it turned off. Later, when communication finally resumed, one anomaly remained. The time-stamped logs from MRO's high-resolution camera contained an unexplained gap. No telemetry between 1:42 and 1:49 UTC on October 7th. A 7-minute hole. No raw images, no sensor readouts, No pointing data. The onboard clock skipped ahead, as though those minutes had never happened. 7 minutes. On a normal day, that would mean nothing, but with an interstellar object moving at 70 kilometers per second, 7 minutes is 30,000 kilometers, enough distance for a mystery to unfold unseen. So when Mars orbiters went dark, maybe it wasn't failure. Maybe it was containment. Maybe the world's most advanced machines looked straight at something they couldn't explain and were told to look away. When the professionals stopped talking, the amateurs began. That's the way it always happens in astronomy. Curiosity doesn't wait for permission. In the silence that followed the ESA blackout, a network of independent observers across Earth started scanning the skies, trying to pick up where the agencies had gone dark. Most of them had no access to billion-euro instruments, just modest backyard telescopes, home-built mounts, and a sense that something wasn't right. The first usable images came from Portugal. A veteran astrophotographer who went by the name Dobsonian Power uploaded a series of stacked frames showing 3i Atlas moving against the faint backdrop of Pisces. His setup wasn't extraordinary. A solar telescope fitted with a deep space filter, modified for long exposure. What made his capture different was what appeared inside it. A lopsided glow with sharp edges, almost geometric, cutting through the usual blur of a comet's coma. The image looked wrong, too defined, too deliberate. Within hours, thousands of people had downloaded and enhanced the picture. Some found what looked like panels, others claimed to see a cylindrical ridge. The online debate split instantly. Half the community called it a breakthrough. The other half called it a hallucination born from noise and overexposure. Both had valid points. The telescope used was never meant for faint, fast-moving objects. It could easily introduce false structures when data was pushed too hard. But still, the pattern persisted across independent enhancements. Over the next 48 hours, other amateurs joined in. Observatories in Chile, Arizona, and southern France aimed their instruments toward the same coordinates. Despite differences in equipment and atmosphere, their results echoed one another. The same uneven brightness, the same suggestion of shape inside the light. One observer described it as seeing a flashlight through fog, except the flashlight itself seems to have corners. Scientists working within universities took notice. Though official observatories were silent, several researchers quietly began comparing the amateur data. They found consistency. The orientation of the bright edge matched theoretical models of reflection, as if one side of 3i Atlas were catching sunlight more efficiently, almost like a polished surface. A natural explanation was possible, but it was narrow. The nucleus would need to be unusually flat, rotating just right to mimic reflection rather than emission. In short, the odds were microscopic. Then came the second wave images. Using an array of small telescopes networked across time zones, a team of hobbyists created a composite video of 3i Atlas's motion over 12 hours. The results stunned everyone. The object's glow pulsed in steady intervals, precise, repeating flashes separated by exactly 11.6 seconds. In astronomy, randomness is expected. Precision is not. The effect could have been coincidence, camera noise, or atmospheric interference. Yet the timing remained constant across recordings made continents apart. Forums erupted. Was this proof of active emission? A natural resonance between light and dust? Or something engineered to modulate? None of it could be verified, but one fact was undeniable. Amateurs were seeing what agencies refused to show. When journalists began asking ESA for comment on the amateur findings, the agency declined to confirm or deny any of the independent observations. Citizen science is valuable, a spokesperson said, but interpretations must remain cautious. The words were polite, but their tone felt dismissive, a way to close the door without locking it. Meanwhile, the images kept coming. In November, when 3i Atlas was briefly visible again from the southern hemisphere, hundreds of backyard astronomers coordinated to photograph it. The same rhythmic glow appeared, faint but steady, right where they predicted it would be. For the first time since the ESA leak, the silence broke not from a press conference, but from ordinary people staring into the night through homemade optics. The professionals had the technology, the amateurs had persistence. And together, though they never spoke in unison, they uncovered something the official record still pretends isn't there. a pattern of light, real and repeating, that no one can yet explain. For weeks, the conversation around 3I Atlas revolved around what could be seen. The leaked images, the golden glow, the missing frames, all visible phenomena. But what no one expected was that the real anomaly might be something heard. Not in sound, but in signal. It began as a background hum. The Mars Express orbiter, still relaying data from the red planet after 2 decades in service, recorded a faint oscillation during its high-gain antenna check on October 8th. The pattern repeated every 41 seconds, buried so deep in the noise that it was initially dismissed as radio interference. But the engineers who cleaned the data noticed something impossible. The signal wasn't coming from the spacecraft itself. It was inbound. At the same time, a small amateur radio observatory in Argentina picked up a nearly identical pattern while scanning the region of sky where 3I Atlas had last been tracked. Their equipment was crude, a cluster of repurposed satellite dishes and software-defined radios, yet the sequence was unmistakable. A repeating pulse, with a distinct carrier drop every 10th cycle. When plotted as frequency over time, it formed a staircase, not random noise, but structured decay. No one called it alien. Not yet. The word structured was enough to cause discomfort on its own. Normally, comets emit radio waves passively. Solar radiation ionizes their tails, producing bursts of static that rise and fall with the sun's activity. It's messy, chaotic, broadband, the cosmic equivalent of white noise. What the observers detected wasn't broadband. It was narrow, precise, and staggered in regular increments. Researchers at the Galileo project quietly cross-referenced public telemetry from Mars orbiters and found matching interference at 3 separate frequencies: 2.3 GHz, 8.4 GHz, and 32 GHz, the same bands used for deep space communication. The implications were unsettling. Either 3I Atlas was reflecting Earth's own transmissions back at us, which would require a mirror-like surface and exact alignment, or it was producing emissions of its own, in bands reserved for human spacecraft. The easiest answer was reflection, but the math didn't fit. The delay between transmitted and returned signals was too short, suggesting the echo originated closer to Mars than the object's known position. That hinted at re-emission light or radio waves absorbed and rebroadcast in real time. A natural phenomenon can do that, but only under extreme conditions, like plasma resonance in charged dust. And yet, the spectral profile didn't match any known plasma interaction. As word spread among independent astronomers, so did the recordings. Hobbyists with dish antennas from Spain to South Africa began scanning the same coordinates. Some heard nothing. Others caught brief flickers, a ghostly repetition of frequencies falling through static, like a code transmitted through storm noise. It wasn't clear if they were detecting 3I Atlas or each other, but the pattern was the same: regular, decaying, deliberate. By mid-October, several university labs were quietly collecting the data. A team at MIT ran a Fourier analysis and extracted a waveform with harmonic overtones that aligned with the object's known rotation period, roughly 3 hours. That correlation couldn't be coincidence. The signal was modulating in sync with 3I Atlas's spin, brightening when its reflective face turned toward the Sunday. When journalists asked ESA whether any of their orbiters had detected radio interference during the observation window, the agency's official statement was brief: no signals of artificial origin have been identified. The phrasing was careful: not no signals, but no signals of artificial origin, and that's where the debate still rests. Some insist the emissions are natural static, dust, and solar noise stitched into false rhythm by overzealous analysis. Others see it differently: a whisper beneath the static, faint but patterned, coming from an object that already defies every natural rule we know. Because sometimes, the most disturbing sound in the universe isn't silence, it's something quietly trying not to be heard. The first time scientists detected nickel in a comet's spectrum, it was a triumph. In 2021, researchers using the Very Large Telescope in Chile discovered faint traces of both nickel and iron gases streaming from ordinary comets within our solar system. The two elements were always found together, twin metals forged in the same stellar explosions, inseparable since birth. Wherever you found one, you found the other. That simple rule became a foundation of cometary chemistry. until 3I Atlas broke it. The anomaly came quietly. During one of the last data transmissions before Mars orbiters went dark, a fragment of spectroscopic analysis leaked from a European instrument database. The file showed elevated nickel emissions, a strong line near 341 nanometers, but the corresponding iron line was missing, completely absent. To anyone outside astronomy, that might sound trivial. But in cosmic chemistry, nickel without iron is like smoke without fire. It doesn't happen. Nickel and iron are nucleosynthetic siblings. They form together inside dying stars, when immense pressure fuses lighter elements into heavier ones. Every meteorite, every asteroid, every metallic body in our solar system carries their combined fingerprint. If one appears without the other, something unnatural has altered the process. Either the material was refined, filtered, or manufactured. At first, the ESA data team assumed calibration error. The spectrometer might have been saturated or misaligned, but after cross-checking 3 separate readings from different instruments, including one aboard the Hope orbiter, the same imbalance appeared. High nickel, near zero iron. The results were logged internally, then quietly removed from public summary reports. When fragments of the data reached independent researchers, the discussion split along 2 lines. The cautious interpretation was that the observation caught a brief plume of nickel-rich dust from a localized eruption, something that could, in theory, happen if the object's surface chemistry were highly differentiated. Maybe nickel condensed in certain layers during formation and was venting alone. Unlikely, but not impossible. The alternative theory was less comforting, that 3I Atlas's surface wasn't natural at all, but selective. A reflective alloy optimized to shed heat, resist corrosion, or manipulate radiation pressure. Nickel alloys like that are common in aerospace engineering: light, durable, capable of surviving extremes. If such material covered even a portion of the object, it would explain both the unusual reflectivity and the thermal inversion seen in earlier readings. It would also mean someone or something built it. The public never saw the full spectral data, but the numbers were quietly verified by independent labs modeling cometary physics. When simulated with typical compositions, no combination of natural ices or silicates could replicate the observed line ratio. Even if the object were coated in metallic dust from collisions, iron should dominate. The nickel-only signature defied every scenario. Then came the echo. Weeks later, radio astronomers monitoring the same region picked up a narrow emission spike at 3.41 GHz, the radio harmonic of nickel's atomic transition. It was weak, intermittent, and faded within a day, but it matched the optical signature's wavelength ratio precisely. Scientists called it the nickel echo. No natural mechanism should produce a radio frequency tied to a specific elemental transition like that. It would require coherent energy, something actively stimulating emission. The simplest explanation was that the object was reflecting existing signals, but no terrestrial or spacecraft transmitters operated at that exact frequency during the observation window. The echo came from nowhere, bounced off nothing, and returned with nickel's atomic fingerprint. After the event, ESA quietly added a new disclaimer to their reports. Certain spectral anomalies remain under review. No mention of nickel, no mention of iron, just an acknowledgement that something somewhere didn't fit. For most scientists, that phrasing was enough to move on. But for those still listening, it meant something deeper, that the strange golden glow of 3I Atlas wasn't just color, it was composition. It was nickel singing in the dark. And whatever was singing, it was choosing its tune. For months, 3I Atlas had been gliding silently through the inner solar system, a faint visitor moving between planets, always keeping its distance. But as October 2025 drew to a close, it approached the one place where all secrets are tested: the Sunday. Every comet's story ends here, in heat and light. The closer an object moves toward that blinding furnace, the more truth its behavior reveals. Ice sublimates, dust burns, metals shine, physics lays everything bare. And yet, for 3I Atlas, the sun has always been more mirror than judge. When astronomers plotted its perihelion path, they realized the geometry was almost poetic. At its closest, 3I Atlas would skim just inside the orbit of Mars, close enough for intense solar radiation, but far enough to survive if its material was unusually strong. The European Space Agency called this the critical observation window, a time when every spacecraft aimed sunward could, in theory, catch a glimpse. But as the moment approached, the agencies grew quiet again. Only a few independent solar observatories remained active. The Solar Dynamics Observatory, NASA's long-running sun watcher, caught something strange, a faint reflective glint crossing the sun's corona, brief, precise, and too cold to be plasma. It wasn't an eruption or flare, it was a reflection, like a mirror tilting through sunlight. The signal lasted less than half a second. To most viewers, it would have been invisible, but to instruments tuned for contrast, it stood out as an unnatural flash, coherent, directional, and symmetrical. That single spark reignited every question. Was 3I Atlas intact, or had it fractured into smaller bodies? Was the flash a fragment burning apart, or something reacting, aligning as it passed behind the sun? Astronomers tried to model the trajectory, but data gaps from the Mars orbiters made it almost impossible to track precisely. The official record called it temporary signal saturation due to solar interference. Yet solar interference doesn't usually produce geometry. As the object slipped behind the sun, disappearing from Earth's view, the radio silence deepened. But then, one of the Solar and Heliospheric Observatory, SOHO, instruments picked up something subtle, a low-frequency oscillation in the background solar wind. Normally, the solar plasma produces chaotic noise, a storm of electromagnetic hiss. This, however, was rhythmic faint waveforms rising and falling at consistent intervals, almost like an echo modulated by something passing through the stream. The scientists who analyzed it called it phase-shifted scattering. To the uninitiated, it meant light and plasma waves were being bent, timed, and redirected as if they'd encountered a surface capable of altering their phase, not absorbing but coordinating them. In simpler terms, 3I Atlas might not have just endured the sun's energy. It might have used it. If that sounds impossible, remember, nature already builds systems that do similar things. Photonic crystals can guide light. Plasma mirrors can reflect it. A surface layered with metallic nickel like the one 3I Atlas seems to possess could hypothetically act as a coherent reflector, using the sun's electromagnetic field as fuel rather than threat. It wouldn't melt, it would shimmer, like a tuning fork struck by solar radiation. As the world waited for it to reappear from behind the sun, astronomers whispered about what the new side might show. If it emerged brighter, it would suggest resurfacing, perhaps outgassing or vaporization. If it dimmed, it would mean disintegration. But if it maintained its glow, perfectly unchanged despite a million-degree environment, that would mean something else entirely. Stability, design, purpose. For now, the sun holds the truth. And in a few days, as 3I Atlas drifts from the other side of that blinding curtain, we'll learn whether we've been chasing a comet, a machine, or something older, something that learned long ago how to face a star without fear. By late October, speculation had reached a fever pitch. The world had been watching 3I Atlas vanish behind the sun, waiting for it to re-emerge, or for confirmation that it hadn't. In the absence of real-time data, theories filled the silence. Scientists, journalists, and even heads of observatories began constructing models for what could happen next. Some were cautious, others radical, but all shared the same question. What is this thing actually doing? The first and simplest scenario was the natural comet. In this view, 3I Atlas was an unusually dense but otherwise normal interstellar body, a survivor from another star system, made of refractory material that simply reflected light in unexpected ways. Its metallic glow could be explained by nickel-rich dust. The strange symmetry might come from rotational fragmentation or solar wind shaping the coma into hexagonal waves. Even the missing heat could be blamed on high reflectivity or poor calibration. It was a comforting theory, the cosmos as we already understand it, but the problem was that every line of evidence pushed back against it. The missing iron, the stationary moments, the controlled light modulation, none of it matched random chemistry. The second scenario was the technological artifact. In this model, 3I Atlas wasn't a comet at all, but a probe, or the remains of one sent across interstellar space either deliberately or by accident. The theory suggested a self-stabilizing object capable of adjusting its trajectory and controlling heat dispersion, perhaps powered by internal mechanisms that still functioned. It might have been ancient, drifting for millions of years before wandering into our system. Some physicists described it as a solar sailing relic, using radiation pressure as propulsion. Others imagined a more deliberate visitor, a machine that paused, scanned, and recorded before continuing its journey. To believers in this idea, the missing frames and synchronized signals weren't anomalies, they were behavior. The third possibility, discussed in quieter academic circles, was the post-natural hybrid, an object that began as something ordinary but changed through exposure to the extreme environments of interstellar space. Over time, constant bombardment by cosmic rays could have fused elements on its surface into an exotic metallic lattice, a quantum-locked shell that behaves like both a conductor and an insulator. If true, 3I Atlas could be a kind of natural metamaterial, capable of redirecting energy and stabilizing itself against heat. It wouldn't be alien technology, but it wouldn't be random geology either, something born from physics we don't yet understand. Then came the fourth scenario, whispered rather than published: the signaler. In this idea, 3I Atlas was neither accidental nor ancient, but active and autonomous object that responded to proximity. The timing of radio pulses, the modulation patterns, even the thermal paradox might indicate a machine designed to harvest and re-emit information. It could be broadcasting not to us, but through us, using the solar system as an amplifier in a network of stars, a cosmic repeater, a node. It's a hypothesis impossible to test, but impossible to ignore once spoken aloud. Each scenario carried its own logic and its own fear. If 3I Atlas was natural, then nature is far stranger than we thought. If it was engineered, then we are not alone, and we've been observed long before we knew it. If it was hybrid, then the universe is capable of manufacturing intelligence through environment alone. And if it was signaling, then contact has already happened, and we missed the beginning of the conversation. For now, scientists continue to model trajectories, compare spectra, and cross-reference data, but the truth may not depend on our instruments. It may depend on what happens next, when 3I Atlas finally emerges from behind the Sunday. Will it appear dim and broken, or brighter, intact, and steering itself toward another planet? Each possibility rewrites a different law of reality, and somewhere, in the quiet halls of agencies that claim to know nothing, every scenario is already being prepared for, except, perhaps, the one that turns out to be true. Every great celestial story reaches a point where light disappears. For comets, that point is perihelion, the moment they slip behind the sun, swallowed by glare and plasma, invisible to every telescope on Earth. In theory, it's a brief silence before reappearance, a pause in observation while physics runs its course. But with 3I Atlas, silence didn't feel like waiting. It felt like control. As the object approached its closest distance to the sun, every major observatory on the planet went blind at once, not because of distance, but because of data. Streams from the Mars orbiters, solar observatories, and deep space relay networks all began to report transmission anomalies. At first, it looked like routine interference bursts of radiation from solar wind scattering communication signals. But when engineers compared the gaps, the timing was too perfect. The outages formed a repeating pattern, as though the entire observation network had been switched off and on in rhythm. Inside NASA's Deep Space Network facility in Madrid, operators noticed something even stranger. During each blackout interval, their ground antennas detected faint carrier waves where none should exist, background static with a slight oscillation, rising and falling every 40 seconds. The frequency wasn't random. It matched the narrowband hum previously recorded near Mars when 3I Atlas had frozen in motion. It was as if the same phenomenon had followed the object into solar orbit. Meanwhile, solar physicists expected a bright flare of activity as the object entered the sun's corona, a burst of vapor, dust, and debris. None came. The Solar and Heliospheric Observatory registered nothing beyond a tiny reflection, a cold, clean flash that vanished almost instantly. It wasn't outgassing. It wasn't destruction. It was presence, silent, precise, and stable. The public heard almost nothing. ESA's channels went quiet. NASA posted a placeholder statement about temporary observational constraints. Even amateur networks that had been feeding live imagery from their coronagraphs began reporting inexplicable interference, blank frames, corrupted pixels, static overlays that looked eerily uniform. Some wondered if the interference was natural, but the consistency said otherwise. It looked generated. It looked deliberate. In the absence of official data, a kind of digital superstition took hold. Online forums filled with speculation, countdowns, and live trackers watching nothing at all. The world was waiting for an event it couldn't see, a moment when the unknown would either reveal itself or dissolve into vapor. The quiet stretched on for days. Inside that void, a few scientists kept listening. A small independent radio telescope in Western Australia picked up what one operator called a low heartbeat, a pulsing drop in cosmic background radiation that appeared precisely at the time 3I Atlas reached its closest approach. It wasn't strong enough to decode, but it was real, a measurable anomaly in the solar radio flux, a blip in the fabric of silence itself. Then, as quickly as it began, the interference stopped. The static flattened, the heartbeat vanished, the sun returned to normal, and the object, the brightest interstellar traveler ever recorded, simply didn't reappear where it should have. Some say it fragmented. Others believe it shifted trajectory, slipping behind the solar wind into an orbit no one predicted. There's even a quiet rumor among researchers that the object didn't vanish at all, it dimmed, becoming invisible to sensors that depend on reflected light. No matter the truth, that final silence before perihelion changed everything. It wasn't the sound of a comet burning away. It was the sound of something waiting, choosing when to be seen again. For now, 3I Atlas exists only as a line of missing data, a blank in our instruments, a pause between two questions. But the universe has a way of ending silences, and when that quiet breaks, whatever emerges from the sun's shadow will tell us whether we've been watching a natural wanderer or the first deliberate act ever performed by an interstellar visitor. When you study the sky long enough, you learn that not every mystery shouts. Some whisper. 3I Atlas began as a faint streak of light, a visitor that should have been ordinary, and ended as a silence that feels heavier than sound. Every instrument we built to understand the universe turned toward it, and all of them blinked at once. Maybe it was nothing more than timing a coincidence of geometry, reflection, and interference. Or maybe we just witnessed the first object to move through our solar system with intent. Either way, the story isn't over. In the coming weeks, as it emerges from behind the sun, every telescope, every dish, every listening ear will turn back toward the same patch of sky, waiting to see if that silence breaks. If 3I Atlas returns dim and broken, science wins mystery, explained. But if it comes back brighter, sharper, perfectly intact, then this becomes something else entirely. Not a comet. Not debris, a message written in motion. Until then, we watch. We wait. And we remember that the universe never hides it, or tests how hard we're willing to look. If you've made it this far, thank you for listening. Leave a like if you want to keep following this investigation, and tell me in the comments where you're listening from and what time it is there. The next phase begins soon when the light returns.